Hi everyone, here is deriving our nifty equations of motion. So all of the equations we're working with come from this basic velocity is a displacement divided by time, and an acceleration is a change in velocity over time. Triangle delta symbol means change. That is important because it does keep showing up. So delta V is just a final velocity, which we'll use Vf, and an initial velocity, which we'll use V0. So change in velocity is just that, so I can make this a slightly longer form like this. Acceleration is final velocity minus initial velocity divided by time, and those should be in parentheses. Our first nifty equation of motion is taking this and simply rearranging it a little bit to solve so that velocity final is alone on one side. And what we'll see there is we'll pull off multiply both sides by time, and we'll add initial velocity, and it will look a little something like that. First nifty equation of motion, and we're going to refer back to step C, that nifty equation, quite a few more times. So line D is a little bit of a strange one. I typically don't tell you can just average two velocities, because that only works if you're driving at those velocities for the exact same amount of time. But if you're dealing with something in a constant acceleration problem, and that is what we're dealing with completely in this unit, we can say something like, well, the average velocity is your final velocity plus your initial velocity divided by 2. Because if you've got a constant acceleration from 0 to 100, your average will be 50. So we'll look back to our original definition of average velocity over in step A. Boom. This one right here. And we can say velocity average is velocity final plus velocity initial over 2, and it's also a displacement divided by a time. Those two are measuring the same thing, are calculating the same thing. We can set them to be equal, and we can rewrite it to solve for displacement. And displacement was just picked as the variable to put out front. It goes a little something like multiply both sides by t, and you'll get velocity final plus velocity initial divided by 2. We'll parentheses it, throw in time, and that's our second nifty equation of motion. We are just solving this part for our displacement. Let's see what else we've got. So part G is looking way back at step C. So for part G, we need nifty equation of motion 1, which is right here. Velocity final initial plus AT. Velocity final equals velocity initial plus acceleration times time. So that's equation C. And we're going to take the equation we just solved, which was step F, and we're going to do displacement is velocity final plus velocity initial over 2 times t. Okay, and what they're having us do here is plug in this part for velocity final like that. So what it will look like is V0 plus AT plus another V0 divided by 2. All that times time gives us this displacement. And what we've done there by substituting in final velocity no longer shows up in this equation. So we've basically gotten rid of it. And what we can do from here is, I guess I'll simplify it a little bit, and I can do V0, 2 V0s over 2 plus AT with this t still on the outside, and then I'll distribute the t, so I'll end up with initial velocity times time plus, oops, that still had a 2 underneath it, plus 1/2 a t squared. So that's just distributing the t each one of these places. These 2's cancel out. At divided by 2 I just rewrote as 1/2 at. And that's nifty equation number 3. Does not care about a final velocity. All right, for part H, we are going to go back to step C, and we're just going to solve it for a change in time. So to do that, we would do velocity final minus velocity initial divided by acceleration. So it'll look a little something like that. And now we are going to do some kind of crazy foiling, which hopefully you enjoyed in math. Step F I rewrote up here, and it is, got to rewrite it again because VF plus V0 over 2, and this one multiplies by time. Part F multiplies by time, but we're going to replace time with this equation, and that way time no longer shows up in this equation. So we no longer need time to solve for it. Okay, had some trouble foiling, have to start over. So this is an easier way to just draw the velocity final, velocity initial divided by 2, and now I'll FOIL out. So first up is the velocity final terms, and it goes velocity final squared over 2a. Then velocity final plus velocity final times velocity initial over 2a. Now we've got a negative velocity initial times velocity final over 2a, negative. Then we've got the negative velocity initial squared over 2a. So that's our FOILed term. These two are easy because they go away, and we'll be left with a displacement is velocity final squared over 2a minus velocity initial squared over 2a. We can multiply both sides by 2a. 2a delta x equals vf squared minus velocity initial squared. And then the last step brings us to our final TNEOM. Velocity final squared is velocity initial squared plus 2 acceleration times displacement. I hope you've enjoyed this installment of physics as a math lesson. These are nifty equations of motion, very important moving on.